Look closely at this harvest. 35 pounds. We pulled these heavy, deeply red tomatoes from a single container bed. The vines are practically collapsing under their own weight. Now, picture achieving this exact yield without touching a watering can for months. We built an environment that sustains itself. Modern top-down watering is a deeply flawed protocol. You pour water onto the dirt. Almost immediately, the sun strips it away through surface evaporation. A massive percentage flows straight out the bottom as runoff waste. We are essentially throwing our resources away on a daily basis. To engineer a better system, we look backward. More than 4,000 years ago, agricultural pioneers in China and North Africa developed a highly sophisticated biological alternative: ancient North African pottery shards. They refused to accept the relentless water losses of surface irrigation. Instead, they forced the water underground. This ancient technology bypassed the topsoil entirely, feeding the plants directly at the source. We can rebuild this system today with minimal effort. When you stack the modern approach against the ancient method, the data tells a brutal story. Runoff waste? The historical blueprint wins every single time. The core mechanism driving this ecosystem is shockingly simple. It is a clay pot. In Spanish, the term translates directly to clay pot, and it is typically pronounced olla or olla. Olla. But we do not treat this as a mere container. It is an interlocking gear in our biological machine. History proves its resilience. The brilliance lies entirely in the material. It relies on a principle called soil moisture tension. By burying an unglazed clay pot in the soil, the water slowly seeps through the naturally porous clay. Moisture seepage. It moves directly to the surrounding plant root zone. The roots pull the moisture. The pot releases it. The system is completely self-regulating, balancing the hydration levels without any human intervention. Before we can build, we need the right hardware. You cannot use just any pot from a garden center. The vessel must be unglazed terracotta. This detail is non-negotiable. If the clay is glazed, the microscopic pores are sealed shut. Water remains trapped inside the walls. We need the pot to sweat. Once we have the correct vessel, we prepare the soil bed. We are constructing a closed-loop autonomous reservoir. We dig a deep central void in the dirt, making sure the surrounding earth is loose and aerated. This preparation step shifts the container from a passive planter into an active, high-efficiency ecosystem. Every cubic inch of dirt must be optimized for rapid root expansion. We are setting the stage for a biological takeover. We sink the unglazed pot into the center of the prepared bed. Day 1. The geometry of this placement is crucial to the design. We bury the Olla deeply, but we must leave its neck fully exposed above the soil line. This exposed neck acts as our only access port. Next, we plant our tomato seedlings. We position them in a tight, precise ring around the subterranean water source. Tomato seedlings. They encircle the terracotta core. By packing them closely, we guarantee the young roots align immediately with the moisture gradient. The plants do not have to search for hydration. It is right beside them. Finally, we fill the central pot to the brim with water. The heavy lifting is over. Our daily watering requirement is permanently deleted. Time accelerates as the system takes over. Day 15. Notice exactly what is missing from the surface. The dirt on top remains completely dry and undisturbed. Because the moisture is delivered subsurface rather than top-down, the method bypasses soil surface evaporation entirely. It eliminates irrigation runoff waste entirely. We are losing absolutely nothing to the atmosphere. Beneath the surface, an invisible process is unfolding. The plants detect the underground moisture gradient radiating from the clay. The roots begin aggressively tracking the water source. Root growth stretches rapidly through the soil. They map the exact location of the clay walls, reaching for the permanent hydration zone we installed. 2 more weeks pass. Day 30. If we pull back the soil, you can see the biological interaction clearly. The roots physically hug the pot. They wrap tightly around the terracotta, pulling moisture directly from the pores as they need it. This interaction is exactly why Olla pots are highly efficient for small-scale gardens and container plants. Drip irrigation and soaker hoses are generally deployed for larger agricultural areas, but in dense container beds, this small-scale clay system radically outscales drip lines. System efficiency. A drip line forces water onto the soil on a timer, whether the plant needs it or not. The Olla pot responds directly to the biological demand of the roots. It never overwaters, it never underwaters. Harvest time proves the concept beyond any doubt. The visual weight of these tomatoes is undeniable. We contrast this massive output against the tiny volume of water we actually supplied over the growing season. The results match the agricultural science perfectly. That is the exact leverage we want in our systems. We engineered an environment that operates independently. We stripped away the labor, we eliminated the structural waste. The final yield speaks for itself. Before you reset the bed for the next cycle, we have one final upgrade. The system has a single point of vulnerability. The exposed neck of the pot can still allow a marginal amount of water to evaporate into the air. To neutralize this loss, seal the exposed lid with beeswax. Beeswax seal. The natural wax completely blocks the final exit path. It forces every single drop of water directly outward into the root zone, where it belongs. Welcome to biological independence.